Okay, well, let's follow up this example with something more general. In general, if we have two vectors, each vector is going to have an x, a y, and a z component. So the first vector, just think of it as vector A, could be expressed as axi plus ayj plus azk, and the second as bxi plus byj plus bzk. That's going to apply to any two vectors. We could take any two vectors and put them into this form. So this is going to be a general calculation of the cross product. So what do we get? Let me just let the camera just a little. Okay, not sure that helped. Okay, well, you should work it out. But I'm going to go ahead. It'll be axi cross bxi, that x on the little low, which is subscript, okay, plus axi cross byj plus axi cross bzk plus that. Okay, now we've just distributed the axi through here. We're going to distribute the ayj through here. So we're going to have ayj cross bxi plus ayj cross byj plus ayj cross bzk plus, well, you write out the rest. I'm going to write it off screen. Okay, I've written it out. Now, the thing, let's just check and make sure I haven't messed anything up here, because if I have, it's going to get kind of confusing for me and for you. The first term, or the first factor in each of these cross products, on the first row should be axi, and we see that it is. The second, it's ayj, and the third, it's azk. So those all check out. The second factor, here, here, and here, should be the first term here, bxi, bxi, bxi. Then byj, 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 bzk, bzk, bzk. So I think I've got it right. Now, let's just figure out what these are. And I'm going to write it off screen, because it's going to be a little tedious. The first one I'm just going to write as ax dx times I cross I. Going one step at a time, not skipping anything. So, similar, in similar format to this, what do you get for each of the other 8 terms? Okay, I've written it out, and if you've written it out and checked it, you want to check that you have I for your first vector in each of these cross products. We do. J for the first vector in each of these. We do. K for the first vector in each of these products, and we do. And then I for the second vector, here, here, and here. J for the second vector, here, here, and here. K for the second vector, here, here, and here. Also, that we have X for the first letter, for the first subscript, and Y for the first subscript in this row, Z for the first subscript in this row, that's a subscript of A, and X for the subscript of B here, Y for the subscript of B, Z for the subscript of B. Just being careful with our bookkeeping so that we write this out correctly the first time, we hope. The next step is to replace I cross I with what that is, I cross J with that result, I cross K. We have all the rules, and the rules are simple. First of all, I cross I, J cross J, K cross K is going to give us 0. So we're going to have a 0 here, and we're going to have a 0 here, and we're going to have a 0 here. Okay, now I cross J, and we might want to go back to our right-hand rule, I cross j gives us k. So I cross j gives us k. We don't always want to be looking at our set of rules. The right-hand rule suffices. Anyhow, I cross j is k, so we're going to have plus ax by k, and then what? Plus I cross k. Now I is out here, k is here. That's going to be negative j. We're going to have ax by times negative j. I could have written that as minus ax byj, and that's the way it's going to come out when we're done. Now, you should finish this. I'm going to do the rest of it off camera. Okay, I've written out the results. So, see if this agrees with what you have. A y bx times negative k, a y bz times I, az bx times j, az by times negative I, and of course zeros where the zeros were. And we can again check that the A has x subscript in this row, y subscript in this row, z subscript in this row. The B has x subscript in this column, y subscript in this column, and z subscript in this column. But it doesn't because I wrote y here. So that's a good thing we checked, because this would have been a little bit confusing. Okay, that's been corrected, and hopefully that didn't cause you any great confusion when you went through here. I will make mistakes. This is not exactly live. I can go back and fix things, but I don't like to take the time to do that because I want to get a good bit of this done. I want you to see a few things, but if I do something dumb enough or misleading enough, embarrassing enough, or just plain old bad enough, I will go back and discard it and move on. So that wasn't bad enough. That was a fairly obvious clerical error on my part. But still, it might have thrown you off a little. Anyhow, you should see the structure of this and the patterns that emerge when you write this out, because that makes it a lot easier to deal with expressions of this nature and symbolic calculations where you have a lot of repetition. It gets a little mindless, a little mind-numbing. Okay, well, now let's go ahead and let's group these by I, j, or k. Okay, in other words, the I vectors appear here and here, j vectors appear here and here, k vectors appear here and here. And let me also note one other kind of symmetry here. How many pluses do we have? We have a plus here, and a plus here. That's a plus in each row, the way we've set this up. Okay, and we have a minus in each row. We have a plus and a minus in each column. Plus and a minus in each row, a plus and a minus in each column. I also take the liberty of pausing when I have to cough or something like that too much. Okay, so anyhow, write this out, and then we'll see a much shorter way and easier way to write this out and actually do the calculation. Okay, this is very straightforward. We'll just have to copy it down. The I, we have AYBZ times positive I and AZBY times negative I. So we have this times I. And similarly for J and K, and we can easily look down here and see where these are. And you should do that on your own, because there are patterns here that are kind of important and give us a little more sense of security on these calculations. Now, I want to look at the order of these subscripts, okay? The positive subscripts go YZ, ZX, and XY. If we write XYZ and then imagine coming back to X so that we have an X here, we could, have XYZ, XYZ. We can have a whole set of X's, Y's, and Z's. But basically, if we think of X, Y, Z, and then starting over so that X follows Z, our subscripts are Y, Z. Okay, that's like this. There's Y, Z. And ZX, well, that's like this. And XY. like so. If we look at the negatives, we have zy, okay, and they go in the opposite direction. We have xz, and we have yx. Also, the one that's missing in each set is the one that corresponds to the vector. In other words, x corresponds to the I vector, then no x here. Y corresponds to the j vector, no j here, no y here. Z to the k vector, no z, subscript z here. And that's simply because I cross I was 0, j cross j is 0, and k cross k is 0. And you can think of those connections if you want to understand this pattern a little more deeply. And these kind of patterns are pretty important. It's good for you to understand these patterns. Now, we're going to come up with a formula that doesn't actually require you to go through all this stuff, but it's important to appreciate what's behind these kinds of formulas. And this is equal to the determinant. Now, you're probably familiar with the definition of the cross product as this determinant or as this expression. Okay, those are the usual definitions, and there's another definition in terms of the geometry of the situation. We'll talk about those. All these things are equivalent. Okay, well, the determinant of this is easily calculated. It's just I times AY BZ minus AZ BY plus J times AX BZ minus AZ BX, and so forth, if you know that pattern. And the definition, of course, is that we're going to expand the determinant in minors on the first row. And of course we could expand it on any row, but we'll expand it on the first row. So it's going to be I times the determinant of the minor that we get when we eliminate the column below I, the AYBZ, AYAZ, BYBZ. And of course the determinant of any 2 by 2 is just this diagonal minus this diagonal. Okay, then minus j times the determinant of that minor plus k times the determinant of that minor. And I'm not going to go through the details of how to multiply determinants or expand them in minors. This is something you either know or you don't. And one way or another, you just learn to do determinants. In any case, when you evaluate the determinant, this is exactly what you get. And this is exactly what follows from this cross product by the definitions I gave you in terms of the I, j, and k vectors. Another thing is, this vector is perpendicular to either this vector or this vector. We can determine that, we can prove that by simply taking the dot product of this vector with this vector. So let's do that. So we do the dot product. This vector here, with parentheses around it, and I've got a cross there where I should have a dot. Let me fix that. Okay, the wet mark isn't even dry, but I've got a dot here where I had a cross a minute ago. So it's dotted with this, which is the product that we got here. So what do we do? To do the dot product is very simple. It's just Vx times this, I component times I component, J component times J component, Vy times this, and Vz times this. So you should write that down. I'm going to do this off screen. Okay, so what you got matches what I've got here. Very straightforward. Okay, then we just distribute. So you can go ahead and do that. I'll write out the result here. Okay, so here's my result. And if we now look at what we have here, we have an AYBXBZ here. Now here we have an AYBXBZ, but this one's negative. So that this one and this one pair up in such a way that their sum is 0. Okay, they cancel, if you want to use that term. I don't like that term. People do it wrong all the time. We have here AZBXBY. Here we have an AZBXBY. And note that those have opposite signs. And then the one that's left over, clearly, if I smudge that Z, would be clear. AXBYBZ negative, AXBYBZ positive, that equals 0.